Do we do the next question?
Yep, so you have to work out ABD.
Oh, isn't it ABD? Wait,
Find find the size of
is
angle ABD.
isn't that just 80?
So ABD is this one. ABD is this one. So we
Oh, okay. So if that one here is 80, that makes the corner, so like, does it make it 50?
not quite, not quite. So let's go back to what we did before, which is we did the simplifying. So if
Mm-hmm.
you're our simplifying, we saw one circle theorem is this one. One circle theorem, we saw that. We got the triangle like this. We
Mm-hmm.
got another triangle like this. And so now, like a puzzle, we work it out. Can you see any other circle theorems?
Can we go back to is it the circle? No, angles in the se segment and standing on the same chord will always be equal.
No, that one. Circle another one.
Is it the angles between the tangent and the side of the triangle is equal to the
Yep,
interior?
that's the one. That's the
I
one.
don't, I don't understand how to do it though.
That's fine. So let's go back to the other thing first. So first of all, draw the simplified version. So now, oops, a daisy, wrong button. Let me get the thing here. Okay. So first of all, we need to draw the simplified version. The simplified version can be like this. Now, fill in what you can. Fill in what you can. So remember, you got 80 here. So if this was 100, this was
80,
80.
40, and then I know that one is this one's 60.
Yep. So what will ABD be?
ABD. Uh, wait, can we go back to the circle theorem just so I can see it one more time?
Yep.
So does that make it 40 here, like 40?
No, no, no. It's close. You've done the wrong side. It's the other side.
Oh,
So
so it's
it's the other
60.
one. It's 60. Yeah. So it's 60.
Mm-hmm.
Okay. So that's your answer. 60. You've done it.
Yeah.
All right. So if I were to use a different color, we're looking for this angle here, which is this one there. And so you've done it. 60 is your answer.
Mm-hmm.
All right. So similar kind of thing. Simplify, look for your circle theorems. And now this one.
Yeah. This one. Okay, so I have to find the circle theorem. So then that means that this one, if this one is 56, that means this is also 56?
Correct. Yeah.
Or
That's
wrong
it.
one?
No,
Yeah?
that's correct. Yeah, that's correct.
Um, that means this side is also 56 because it's an isosceles because it's on the middle.
Not quite. No, not quite. Not quite. Not quite. No.
Um,
Okay. So remember, before anything, simplify. Draw the simplified things outside of the diagram. So do it by the side, anywhere on the screen. Yeah.
So then we need to
Now,
find,
what are you trying to find? Yeah, highlight what you're trying to find. Use a different color.
we're trying to find angle. Wait, can you scroll down first? Wait, angle are we trying to find?
Yeah, that's the question. We are trying to find CAO.
CAO.
Yeah,
C
CAO.
C A C A O. Okay, does that mean that since that one's 56, it's double? So 56,
Good,
so this is
good. Yeah,
112,
yeah, good.
making um this 248. And if we add those all together, makes this 21, which means angle CAO is 21.
I think so. Let me double check. Um, how did you get 21 so quickly? Can you go through that?
Yeah. So this this and this side, they're like both
Yeah,
56.
yeah,
Um, which makes here double that. So it would be
yeah,
56, like 56 times 2. So
yeah.
it's
One, one, 2.
112. Here, which makes it here like minus 360. It would make it 248.
Yeah, correct.
And if you add all those numbers together,
Yeah.
it would give you 339. So you minus that by 360, and then here you get 21.
Not sure. You got the right idea, but I'm not sure if you got 21 by coincidence.
Mm.
Um, so here I would. Where is CAO? Use a different color to highlight where CAO is.
CAO here. Like here. Wait, I'll redo it.
Yeah.
Here.
Mm, yes, CAO. That is CAO. Correct. That is CAO. Correct. So 360. Yeah, 360 minus that. Yeah.
Yeah.
Yeah. So what is the thing that's making me hesitate is what is your angle here on the outside? So let me show you what I mean. Oops. Let me show you what I mean. So if we have this, this is 35, that's obvious. This is 56, we got that. What is this outside one? Because the inside is 112. What did you say what the outside one was?
It would be wait one second.
360, 360 minus,
248.
yeah,
248.
248. And then you did 360 minus all of those angles. Yep.
Yeah.
Yeah, that's correct. Yeah, that's correct.
Mm.
Yep, correct. Well done. Okay, let's go to the next one. Very good. There's also other things that you could do, by the way, just since we're on it. Because this is the thing, like sometimes you just don't see it. Only afterwards you can see it. So you
Mm.
can do this many ways. So you could have turned this into a triangle. Okay, so if
Yeah.
you did that, that is 35, 35, and then this would be whatever it is, 180 minus that. Not to say that we don't know what the answer is, but just kind of continuing there. Then you've got this triangle that comes here.
Mm-hmm.
Um, then you also have, because this is 56, it's good for us, good to know. 56, so that's fine. What else? What else? What else? Um, if this is 56, we can work out what that one is going to be, because it's going to be 56 minus 35, because we have 35 here.
Yeah.
And so 56 minus 35 is 21 as well. So we could have
Mm,
done it like that. That gives us 21. Because why does it give us 21? Because if this is 21, this is also 21. And that's what we're looking for.
yeah.
Yeah, so that's another way of doing it. So that's another way. What else could we have done? The reason why I'm going through it is just so that you can see there are many ways to do it.
Yeah.
Sometimes you'll just see one way, another way you'll see data. Another thing to recognize also is that this is 90 degrees.
Mm,
So if you recognize that was 90 degrees, then you would know that this angle here would be 4 more makes it 60, 34 degrees. So again, you have another triangle here, which makes it 34, and that would be 34. And so if this is 56, you have a bigger triangle here.
yeah.
You've got 35 and 34. That makes it 69. Then you've got 56 here. And then if that bit is 34, you just need a little bit more to make it 180, if that makes sense. Because that, if that is X, all of that added would make 180. Make sense?
Yeah.
So lots of possible ways to solve these kind of questions. So what you did is correct, absolutely fine. And it's just that sometimes when you see different ways, it just helps you for the future. Let's go to the next one. This is worth 4 marks, and you can see this is a mixture of circle theorem and other things.
Okay. So the angle, so B BAD, wait, BAD,
You
BCD.
can you
So,
can label on the screen as well. And remember
mm,
simplifying.
so if that is 20, that makes wait, A, B. So if that one is 20, that means I think I'm a bit lost.
Okay, with this one, simplify again. So what circle theorems can you see? Um, what circle theorems can you see first of all? So
I
step one,
see
which
the,
circle theorem?
I see the circle theorem 4. I see circle theorem 8. No, circle theorem 6 or 8.
Circles. So just highlight on the screen which ones.
I
Um,
see this one. Oh wait, it's not right
label
here.
label them 1, 2, 3. Yeah, so that's number 4. Label them 1, 2, 3, 4. Just this way you won't have to. When you say a number, I'll understand.
1, 2, 3, 5, 6, 7.
Yeah, correct. I agree. I see 4 and 6 as well. So now on your screen, on the screen here, draw out the circle theorems.
So
No,
let's
what I mean is like this. Rather than doing it like that, what I mean is like this. So you actually draw out the circle theorems. So one of them is like this. Another one is that one. You
mm,
actually have two of these. You have one that is a bit like that as well. Can you see?
yeah.
So you got one with 20 and another one without 20. And now you just kind of fill in the information now. And what are you trying to work out? Where's SPA?
SBA is this one here.
Not quite, no. SBA is
Oh, here, just this one. Like only this one.
yeah, that's right. So what you should do is feel free to just SBA like that, then it's a bit easier to see. So just do it like that, no problem.
Yeah.
And now
So
fill in the information that you're given.
so then I know that B and D equal, so B and D equal 180,
Yeah,
and that A and C equals 180.
good. Yeah, good.
And then do I minus 180 from 20?
Well, you don't have enough information to minus. So you can't do that because if it was all of that, because at the moment, this is 20 and then you got a little bit, you don't know how much that is. It's all of that. That's your B. So at the
Yeah.
moment, you can't use that. So try again, read through the information. What information do you have that's missing that you haven't used? You've used the first line. You've used the second line. You've used this. You haven't used
Oh,
this
that
information.
BAD. Okay, so BAD. So this line and BCD, that one is 3 times bigger. Like BAD is 3 times bigger than BCD. So, oh, so then 180 divided by 4 makes 45. So
Yeah,
then just times that by 3
good,
makes 135. So this is one BAD 135, and this is uh 45.
good, good.
Um,
Okay, that
so
is all
that's
correct.
SBA. So now I need to do 135 plus 20 minus 180. So then this is 25.
Yeah.
And then that number is this 25 also? Or
No,
no?
I don't know. We are not given anything about that. So you can't say that's 25. Now, I want to highlight something you've done. You've said this is 25. Now, you know your simplified versions. Can you update your simplified diagrams?
Oh yeah, so that 25 and that's 135.
Yeah. So can you see anything there?
No, not really.
Not really.
Mm-mm.
You've actually answered the question.
Oh wait, actually,
Yeah, look closely. What is that circle theorem?
is it circle for
We did it at the beginning. So what is that
oh,
number?
it's the one like this is 25.
Yeah, it's the angled segment theorem. So that's it. You've done it.
Hmm.
Yeah. So you didn't realize you've actually solved it. You just had to see that angle circle theorem.
Yeah.
Yeah, and this is the thing, you're so obsessed by the little bit of detail, then you forget the wider picture. So when we started with the wider picture, the simplified versions. Then we went into the detail. So it's just to constantly looking at the detail, looking at the bigger picture, looking at the detail, looking at the bigger picture.
Mm,
That is 25. Well done.
thank you.
All right. Have you copied all of that down?
Onto my like thing?
In terms of, do you have any notes? Are you writing anything down?
No, I'll write
Okay.
it down now.
I'm recording it, so for the future ones, you can write it out and you can watch the video later.
Okay.
Yeah, as long as it saves, hopefully there should be no issues. But let's continue. Let's go to the next question. Did you see the other video I sent you from last week's lesson?
Not yet.
Okay, I'm sure I sent you the link, but I'll do the same. I just realized last time, that I can press record and then you can have it for revision. I'll do the same thing with today's lesson. Right, try this question.
Okay, so we'll separate it first. So that's 60, and that's the other shape. So then we know that that is 120.
Good, yeah, good, very good. Was this a straight line? Good.
Um, what else do we know from this?
Can you see any circle theorems?
Yeah, I can see for this one, it would be oh, which means this one is 60.
Yeah. So yeah, let's draw the
Should I draw,
circle on it. Yeah.
um,
What are you trying to work out? What is your angle you're trying to work out?
BCD?
Okay, use a different color just so that you know where that is. Okay, good. Yeah, good. All right, let's still stick to simplifying. Can you see anything else?
Um, can we look at the angle theorem, circle theorems again?
Yep. Is it number one? No. Is it number
No,
two? No.
no,
Is it number three? No. Is it number four? Yes. Is it
yeah,
number five? No.
yeah, no,
Number
okay,
five? No, I don't think there is number five because it's a radius. There's no center. Number five has a center. Can you see with the green line? This
yeah,
doesn't have a center. Number six, again, has a
mm.
center line. It doesn't have it. There's no number seven and no number eight. So that's it. You've done it. There is something else you might not be able to see. You also
Oh
have a
yeah,
large triangle here.
so
Is that what you
that's
were going to
all
say?
180.
Yep. So you can draw the large triangle is there as well.
Yeah, so
Yeah.
then,
So now, again, like last time, you need to use all the information. At the moment, you haven't used the ratio. What does the ratio say?
it says that E EAB is twice the size of BCD. So I need to find, so then 180 divided by 3 is 60. So
Very good
then,
thinking, but I'm going to stop you because that works if it's an equilateral triangle. Are we told it's an equilateral triangle?
no.
No, so we can't use that information. I'm just going to tweak your working out a little bit. I'm going to tweak your large triangle because this is important. Okay, so now fill in, you've done some working out, fill in all the information.
Yeah. So this is 120. This one is 60.
Okay, so now on your large triangle, you also have 60.
Yeah, so I know that's 60.
Yeah,
Um,
put 60 on it.
yeah, I did. Oh yeah, here, 60.
Yeah. And now use algebra. EAB, BCD. Do you know what
E
BCD is?
BCD, not yet. I'll just, so do I put 2x and x?
Yeah, that's it. Now you can solve it. I gave too much away there. Sorry. Can you solve it now?
Yeah, so 180 minus 60 divided by 3. So this is 40 and this is, wait, no, that's not 40. This is 80 and this is 40.
Yep. And have you worked BCD?
Yeah, so BCD is 40.
Correct. Yeah, you've done it. Well done. So you have to, on this one, again, you're using ratio, and using ratio, you're introducing algebra. So that
Yeah.
was perfect. That was excellent. All right, let's go to the, do you want to copy that down?
Oh, wait, too late. Wait, I can copy it down now if I go back. Wait, I think it's a bit messy now.
Okay, okay, all right. Next one, we'll copy it down. Right, let's go to the next question. This is worth 3 marks.
Um, so I'll draw the triangles. We have this one here. Like, I don't know if I drew that right. Oh, and then there's this one, and this one's 32. Any angle theorems here? Well, I know this whole thing is 180, and then CAD is a tangent, which makes this 90 degrees.
Good, yeah.
So then we already have 32 plus 90. So this is 58,
Correct.
and that's like, so this is 122. So CAB. So I know this is 90, and this is also 90 degrees. So then, are these both the same degrees, like these, like CDB and ABD?
They could be. Why would they be the same? What would make them the same?
If they were isosceles?
Good. Are they isosceles?
No.
Why are they or why are they not isosceles?
Wait, they are isosceles because they're standing on the. Wait, they're not isosceles because it's a right angle triangle.
Okay,
Or no,
which
it's not.
use a
Oh,
different color. So, because I'm a little bit confused.
so this one and this one are they the same?
Okay, this one and this one is not the same. No.
No.
How are
Okay.
they? How are they isosceles? What
Uh,
tells you it's an isosceles?
Nothing. I just thought it's because it's like sitting on the line.
Okay, yeah. So a good try, but unfortunately not. But there is something else that is isosceles. And so this is why, when I say simplify, you're drawing on the diagram, your diagram has become very messy. Whereas if you simplify and put your diagrams separate to the main diagram, it might make it easier to
Yeah,
see
I think I
things.
figured it out. This is the what it's equilateral to. So then 180 minus 122 divided by, so 180 minus 122 divided by 2. So they're 29. So this is 29, and then I minus that by 45. So it's 16.
29, 25, 26, 27, 28, 29, 29. 16. CAB is 16. How did you get CAB 16?
Because this is 90 degrees, which means the other side's also 90 degrees.
Yeah,
And if that's an isosceles,
yeah,
that means, and we know this is 122 here,
yeah.
that means that 180 minus 122 divided by 2 makes the angle for the both sides, and then I just minus that by 45. Oh, I'm supposed to minus it by 90 degrees, my bad. So it's 61 actually, the other way around.
Yep, 61 is correct. But your working out is very messy. It's very hard to see. It says, work out the size of CAB. You must show all your working. So
Mm,
now, what you want to do is present it nicely so the examiner can understand. It is correct. 61 is correct.
yeah.
So what you might want to do is, see what I would have done. The only thing I'm saying that should do, you could do is
Mm,
this. Um, all of that is correct. We need all of that. So this bit here, just to kind of highlight it, this triangle, if you just drew it out separately here, and then you would have seen this is 1, 2, 2, and this is going to be 29, like you said, and that's 29. The other thing you could have spotted is this. If you know it's 29, this must be 90.
yeah.
And so all you had to do there is 90 minus 29 equals 61. It's all the same thing, but you get the idea.
Hmm.
All right. So, yeah, just my only thing is keep your working. And so it's not it's not anything bad. It's just like you've done your working out. Now you need to present it to the examiner. You need to make it, whoever's marking it, they need to understand what you're doing.
Yeah.
Well, let's go to the next question. So this one I will add, it's worth 5 marks, more marks. So you do your working out, and at the end, make it neat for the examiner. Off you go. And also it says you must give a reason for each stage of your working out. So what I tend to do is, oops, can I do something else here?
Yeah.
So what I tend to do is if I go back to the previous question, like you were doing the working out. As you go along, you write down your working out. So here, if I use a different color like orange, here angles in a triangle equal 180, just so that you remember what you're doing. Does that make sense?
Yeah.
Straight line equals 180. So as you're doing it, you're writing the reason down. So this way you don't lose on the marks. Make sense?
Yeah.
Okay, off you go.
So then, so wait, but it's hard for me to write on here.
Yeah, no, I know. So this way, write it on your paper, and then you can at the end show me it with your video camera.
Mhm.
So do your working out as you need to, and then do the
So
other
this
bit.
is equilateral or no?
Not equilateral,
No,
isosceles.
this one's equilateral.
Equilateral would have all lines the same. It's two lines are the
Oh,
same.
so those are isosceles.
Yep, they are isosceles.
So the information we already know is that this is 40 degrees. Um, and that these two angles are the same. So that's 180 minus 40. I just don't know how to explain it. Like, can we do that? Like, how the explaining part also?
Yeah,
Like,
so as you're doing it now, why are you doing minus 180?
because
Because,
it's an isosceles.
yep, so angles in a triangle equal 180, and you're saying isosceles triangle as well.
Mm-hmm. Um, so two angles are the same, making 180 minus 40 equal 120 divided by 2. So then, so it's divided by 40 divided by 2. So this is 70 and this is 70. Wait here, 70 and 70, which informs us that we know this is 90 degrees because it's a circle theorem.
Unfortunately not. That's not 90
It's
degrees.
not.
No, because it's not a tangent. It looks like a tangent, but it's not a tangent.
Oh, well, is this one here double this one?
What circle theorem tells you double that?
Circle theorem 2?
Circle theorem 2. Circle theorem is from the center. There is no center there. Circle theorem 2 uses a center.
Mhm.
Yeah, this is a center. There's no center.
Okay.
There's another circle theorem. So go back to
Oh, it's this
simplifying.
one. I
Which
know.
one?
It's also like a square here.
Okay,
So
so
that's
which number?
also
One, two,
number
three,
4.
four. Number four. Correct. Yeah, number four.
So if we know this is 70 and this equals 360 overall, and then these two, A and C, they equal to 180. That tells us that this is 110 and this is 110. And then 180 minus 110 divided by 2. So this is 35 from each side. And then we're trying to find ADE. So if this is 70 and this is 35, that means 70 plus 35 minus 180 means that this is 75. So the answer is 75.
Correct. Well done. Now you just need to make sure you've written the theorems, your reason for each stage.
Mhm.
So you've said angles in isosceles, angles in a triangle, and then you
Yeah.
need to make sure the circle theorem, you get the wording of the circle theorem correct as well. And
Uh-huh.
so the wording is going to be, you can just say cyclic quadrilateral. Cyclic quadrilateral is good enough.
Mm.
Let's look at the mark scheme. This is paper 2, June 2019. Paper 2, June 2019. And the mark scheme for question 18 is there. So when you say, and now this is important, by the way. Can you see here? It says angles, it's plural. If you
Mhm.
say angle with one singular, you don't get the marks. It
Yeah.
sounds very strange, but it's very important. So here, can you see the underlined words you have to write down? Opposite angles of a cyclic quadrilateral add up to 180.
Mhm.
Angles in a triangle add up. So angles, not your singular, plural. Angles on a straight line. All right, because that's another one you did. Anything else? Yeah. So as long as you've got those underlined words in there, you are okay. You get the full marks.
Mhm.
All right. And you can see this question, you are given 2 marks.
Yeah.
Okay. All right. I did say I'll look at your thing, but I'm not looking at it. On the next one, we'll look at it.
Mhm.
I'm conscious of time as well. All right. Question 4.
4. Okay. So there's I already see an angle theorem 2, like here.
Good. Good. Very good.
So I'll draw that out.
Yeah. Good. Very good. Simplified
So
version.
if this is 320, that means we have to divide it by 2. So circle theorem 2. 1 second. Um, can I just write the circle theorem or do I have to explain it too?
It says give a reason for each stage of your working, so you have to write it down, unfortunately.
Um,
And it's a question worth 4 marks, so it's worth a lot of marks. And communication could be 2 marks, so we'll see at the end with the mark scheme.
So this is 66. So, like the information
May-
I know so far is that
Maybe maybe you can do this in your writing pad now, so it will be easier. Then this way you can write it properly, so you can draw the sketch on your writing pad as well, on your
okay.
paper. So hopefully we've built confidence by doing questions. Now we can write it out properly.
66. And then we know then angles in a circle make 360. Here's t minus 132. 228. So 228. Uh, um, so we know overall the whole thing's 180. So I don't write here, right?
You can, if it helps you, you can. But I'm
Yeah.
encouraging you to write on your pad as well, so you can tell me your final answer at the end as well.
Ready. Uh, 16, not 66. I found the answer. It's 98.
Very good. Well done. Very good. How did you get it is the question. You've been working on it. Let me see your working out.
Yeah.
And let's see, we'll check the mark scheme in a second.
I don't know if my working out was perfect, but
All right. It's looking good. You only thing, did you write down circle theorem says angle at this
no, I
angles?
don't think I did.
All right. The top part is that's part of your working solution, yeah?
Mm.
Yeah, okay. That's fine. All right, let's see the mark scheme. 98 is correct. So we are looking for paper 2, June 2022. Mark scheme. 98 is correct. So did you write down the angle at the center of a circle is twice the angle at the circumference?
Hmm.
Can you see the underline angle at the center twice the angle at the circumference? Those underlined words are
I
important. If you
said it
don't,
was double, not twice.
double is okay. Double the angle at the circumference. Underlined words need to be shown.
Hmm.
reasons need to be linked to their method. So you can see there. So double the angle at the circumference. And then did you write this down? Opposite angles of a cyclic quadrilateral.
I didn't write that.
Okay, that you have to write that. So you missed out on you didn't. Yeah, you did miss out on the communication mark. On this question, the communication mark is only worth 1 mark, but you needed to
Mm,
have both of them. You needed to write both of them for the full marks. So
yeah.
opposite angles, plural, of a cyclic quadrilateral add up to 180. Right. So this is the reason why, last time I made you write it out. It's simply because of this reason. Because if you don't write it down, you don't get the communication mark. The good thing with this question is the communication word mark was only worth 1 mark. Sometimes it's worth two. There was the other question we did earlier where it was worth 2 marks. So you can see that. Are you ready for the next one?
Yeah.
All right. Same thing again. Write your working out down. And this one is worth 4 marks again.
Find ADC. Okay. Just a question, is this like 90 degrees? Like, wait,
Right on the screen, or which
here?
angle are you referring
Like
to?
those ones?
Yes, they are. No, they're not. They're not.
They're not. Oh.
They look like they are. They could be, but we're not told they are. So it could be. It could be by coincidence, but we can't say that. They are definitely opposite angles, and opposite angles are equal.
Hmm.
So they're definitely opposite angles, but they are not 90 degrees.
Okay, can we see the circle frames like really quick?
Yeah, yeah, we can. Which number is the circle theorem?
Circle theorem 1.
Is it one? No, it's close. It's not
No.
one. It looks like one. But here, can you see that this is the thing here? Here, it's not going through the center. Whereas on this one, it is going through the center.
Is it angle theorem 3?
Angle theorem 3. Um, nope, because angle theorem 3 is a diameter. It's going through the center, whereas our one is not going through the center. Our one is not going through any centers. There's no diameter here. That would be a diameter. That would be a diameter. But these are not diameters. This line is not a diameter because it's not going through the center.
Yeah.
So it's not that. What's there? So it's not one, it's not three. What else could it be?
Could it be
It's not 8, it's not 7, it's not 6, it's not 5, it's not 4. There's only one left.
2?
2, yeah. So sometimes it's
How is
just
it?
by elimination. It's a very tricky one, but here, if we draw it here, if you imagine this and this like that, can you see?
Mm-hmm.
That's why it's just because there's an overlap. So because there's an overlap here, that's why it's a bit tricky. Can you see that?
Yeah.
So that is the toughness of this question, actually. If you didn't spot that, then it's very difficult to work that out. But once you spot it, it should be easy to work out.
I still don't see it though.
Imagine, so let me use a color. Can you see this line here?
Mm-hmm.
Imagine that line was here. And I'm going to use a different color. This line here, imagine it was here, there. Can you see it now?
Yeah.
That's what it is. So that is the tough thing with this question. That is the theorem.
So that means that so does that mean that this is like this one? Oh wait, it's not letting me write. Here and here, that's like one of those. Like this is 32.
Yes, that's correct. Yeah, that's correct.
And then that means that 51 plus 32 equals. So that's 97, which means they're both 97, which means, so like here they're both 97.
Yeah, I get what you're doing. Yeah.
Yeah, and then, which means that's, so 64 plus 97 minus that. So this is 19.
The final answer is 19.
Yeah, it's 19.
You sure?
No,
Doesn't look like it's 19.
is it
You're nearly there.
71?
You're nearly there.
Is it 71?
What's your working out to get 71? Yeah.
Yeah, 19.
90 minus 19 is 71. Yeah.
Yeah.
Yeah, that's correct. 71. And it says write down any circle theorems you use, and it's worth 4 marks.
Mhm.
Are you ready to look at the mark scheme?
Yeah.
Paper 1, May 2023. Paper 1, May 2023. Question number 21. 71. Well done. Okay,
Mhm.
and then if you look at the wording, there is a 1 mark for communication, and you have to write down the angle at the center of a circle is twice the angle at the circumference. Or remember, there's another theorem you used, which is it's 90 degrees. So the tangent to a circle is perpendicular to the radius. Yeah, so you could use that. It also has opposite angles of a cyclic quadrilateral. How did that one come about? Opposite angles of a cyclic quadrilateral. I can't see that one. Alternate segment theorem, can you see that there? I
Mhm.
can't see alternate segment theorem there. But you could use different working out for that. So yeah, so as long as
Yeah.
whatever you've seen, so you can see there's lots of ways to do it. Let's look at the work solution that this person has done. What have they done? Did they do it the way we've done it? You've done it or not? So they've done it the way you've done it, exactly like that. Yeah, so they've done it like that. What's interesting to see is how do you use alternate segment theorem here? That's an interesting thing. I can't see alternate segment theorem. It's an interesting one. But anyway, there you have it. So yeah, you've got some extra questions there. In your own time, you can go through these questions. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plenty of practice for you to do.
Mhm.
And then you've got mark schemes on Maths Genie, which you can use to kind of go through them just like how I've shown you. Okay?
Yeah. Okay.